So let's continue our lecture video in Geotechnical Engineering with the topic classification of soil. So let's solve for sample number 4. The given data shown is a sieve analysis of soil samples A and B. Letter A, classify soil A using Uscs method and use the table. For B, classify soil B using Uscs method using also the table. Okay, so let's start with the soil A. So using this table for Uscs, so let's classify soil A. Now again, as we discussed in the previous video, we need to take this from left to right. So look at this condition at the leftmost portion. So it says there, coarse-grained soil and fine-grained soil. So we need to choose which one to use based on the data presented in the table. Okay? So according to this first criteria, it says there, more than 50% retained on number 200 sieve. So we need to look at the data for number 200 sieve. So this is number 200 sieve. And it says here, under soil sample A, the percent passing here is 4%. Now, what can we say about the data wherein the percent passing for number 200 is only 4%? So again, if this is number 200 sieve, it means 4% passed, or so there is 4% that pass through the sieve number 200, meaning finer materials or materials that are lesser in diameter than the sieve number 200 is only 4%, meaning there is 96% retained on number 200. So we can therefore conclude that this type of soil is coarse-grained soil. Okay? So coarse-grained soil because more than 50% is retained on number 200 sieve. Or we can say it this way, if it is more than 50% retained, meaning it is less than 50% passing. Okay? So we will choose the upper portion, the coarse-grained soil, not the fine-grained soil. So let's put a check mark here and then an X mark here at the lower portion. Next, let's go to the next criteria. It says there, so we're concentrating on this upper portion of the table. So let's choose between these two. Okay? Either we have a gravelly soil or a sandy soil. For gravels, it says there, 50% or more of coarse fraction retained on number 4 sieve. Okay, so the concentration is on number 4 sieve. So again, let's have a look for number 4 sieve. So it's this one. Number 4 sieve, it says there, percent passing is 90%. Meaning, in number 4 sieve, 90% passes it, or 90% finer material, and what's left or retained is 10%. So let's go back to the criteria here. So which one will we use? So what can we conclude here? 90% is passing, then 10% is retained. That is a finer type of soil. So if it is finer, therefore, between these two, we will choose sandy. Okay? What does this part here says under sandy? It says there, more than 50% of coarse fraction passes number 4 sieve. So 90%, or that is 90% is greater than 50%. So therefore, we will concentrate on this portion and not here. Okay? Therefore, what's left here is to choose between these four classifications. So we have SW, SP, SM, or SC. Okay, let's go to the next criteria. Concentrate on this portion here. So it says here, if less than 5% passes number 200 sieve, therefore the criteria is either of the four of this. If more than 12% passes number 200 sieve, then the criteria is, or the soil classification is among these four. But since we did not choose gravel here, or it did not fit the gravel classification, therefore we can eliminate GW, GP, GM, and GC. So what's left is this 4. Okay, and this 4 is similar with this one here. Okay, again, let's go back to number 200 sieve. So number 200 sieve says there we have 4% passing. So if we have 4% passing for number 200 sieve, therefore this is the soil type, or this is the criteria that it fits, not this portion here. Okay, not even this one. Right, so eliminated SM and SC. So what's left is SW and SP. So we will choose between these two. Now, the category for SW and SP, for this classification, we need to satisfy this one here to fit SW. If we did not satisfy this portion here, therefore the answer will become SP. Okay, so we need to solve these formulas here, the CU and the CC. Now, the formula for CU is, we have there D60 over D10. And if the answer here is greater than 6, then we have a check mark for CU. Then for the CC, we have the formula D30 squared all over D10 times D60, or that is D30 squared all over D10 times D60. Okay? If the answer here is between 1 and 3, therefore we will have a check mark for CC, and we have the answer SW. But if one of them is wrong, or the both of them is wrong, therefore this category is fitting. Okay, so let's solve for these formulas. Now the question here is, where can we find the value for D60, D10, and D30? So we need to find the values for so D10, D30, and then D60. So what's the value for this? In order for us to answer the CU equals D60 all over D10, and CC equals D30 squared all over D10 times D60. Okay? So we can have two methods in solving for this, for the values of D10, D30, and D60. We can solve using the graph, or we can solve it using the calculator technique. So if we use the graph, so where is the graph? Okay, so here is the graph. So I already plotted it a while ago. So this is the graph of soil A. Now, if you look at the criteria or what we are looking for, we are looking for, what does it mean again for D10? We are looking for the diameter at 10% passing. Now, the problem here is that at the percent passing here, we don't have a 10, a 30, and a 60. So what I mean here is 10% passing is between 17 and 18. So the 10% passing is located here. And the question here is, what's the diameter at 10% passing? And then we have here 30% passing between 34 and 22. And then we have the 60 between 64 and 54. Now, some of you might conclude that why not divide it or do some interpolation? Well, if we use linear interpolation here, we will get a wrong answer. Why? Because the graph for this is logarithmic and not linear. The difference between the linear and logarithmic graph is that for linear, they are equidistant. Okay? The x and y is equidistant, meaning if we have here 1 unit, we have here 1 unit here, another 1 unit, 1 unit, 1 unit, 1 unit. But if we are looking at a logarithmic graph, so as you can see, the space is decreasing. Okay? So compare this portion here up to this portion. So we cannot just linearly interpolate just to find the 60% the 60% diameter. Okay? So the first method is graph. Let's find the diameter for 60% using the graph. So here is the 60%. And therefore, the diameter here, so using this line, the red line here, it is equivalent to what diameter in the x-axis? So for D, this is D 60. So this is D 60, D 30, and then this is D 10. Okay? So we can assume the value for D60 here as, if this is 1, therefore this is 2, therefore it is 2 point, maybe 2 point something, 2.5, 2.6. Okay, so let's say we have here 2.5 because it's decreasing here. So let's say it's 2.5. For D30, we have here 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Let's say that is maybe 0.60 something, 0.60, 64, 65. Okay, so that's based on our sketch. Then for D10, so this is D10 here. So for D10, we have, this is 0.1, and then if this is 0.2, therefore it is in between 0.1 and 0.2. Let's say we have there 0.15. Okay, so let's say it's 0.15. Okay, so these are approximated values based on our sketch on the logarithmic scale or logarithmic graph. So this is going to be time consuming because you will need to plot and then look for the diameter that is in the 60% passing 30% passing and 10% passing. But what about the second method? If we use the calculator, will we find a value that is near? What I mean by near is that since we sketch the graph, so there is higher percentage of error because the values that we get here depends on how accurate we plot the points. So if your hands is as shaky as mine, so as you can see here, my graph is shaky. There might be an error in, there will be an error in determining the diameter. Okay, so let's use the calculator here. The second method, let's use the calculator. So I'm thinking where I would write. Okay, using calculator, let's currently I'm using here Casio FX115ES. So look in your calculator if you have these following functions. Okay? So if you're using a calculator Casio here, just as I am, so I'm using FX115ES right now. Actually, in 991ES, you can find these functions too, right? So go to mode. Go to mode. Then choose here stat. Choose stat mode. Okay. Next, under stat mode, choose there since we are using logarithmic graph, so you are using ln of x. The number 2 there, it says there a plus bx. You can use that for the linear interpolation, but since we are using logarithmic scale, therefore we are using ln x. Okay, so choose ln x. Then you will find another data or another function there. Here, 2 columns. We have their x and y columns. Now, here in this x and y columns, so I should elaborate this one. So, under x and y column, the x here is actually or let's put it as the diameter, and then the y, let's put that as the percent passing. Okay. So there's an x and y column there. Okay. Now let's go here again. Let's solve first for the D10. And for D10, you see here that it is in between 17 and 19. So this is the data that you will need at this portion here. Okay. This 2 rows here. Okay. Because the value for the diameter of 10% passing is in between 0.25 and 0.149. So we will write here for D10. This is okay, so this is 0.25, and then we have here 17 and then we have 9, and then 0.149. Take note, it is in between here that we will find the answer. So what happens here is that okay, so how can I explain this part here? So we have here the 10% passing, right? 10% passing. Then here is the unknown. So the unknown here is x. So let's put there x. Okay? So input in your calculator the first row as 0.25 equals 0.149 equals, okay, and then move to the next column, the y. Input 17 equals, then input 9 equals. Okay, so after you put all these values, you click the AC mode. Okay, so click AC. Okay, and then click shift. So shift, and then look for the stat. So for the number one key in your calculator says there stat. Shift and then number 1 there stat in your calculator keys. So shift 1, that is shift 1, and then you will choose number 7, that is reg. Or if you're using other calculator there, sometimes it says there number 5. Reg is found at number 5. Okay? But in the calculator that I'm using right now, it says there 7 reg. So click 7. And then since we're looking for the unknown x, because y is given, therefore we will choose there number 4, which is this one here. Okay, so number 4. Then in your calculator, you will see there x bar, something like that. Okay, since we are looking for the D10 here, you will put 10. So you type 10 before that x bar symbol. So that is equals 0.159. Okay? So therefore, we have here D10 equals 10 x bar equals 0.159 mm. Okay? So we now have a D10 value of 0.159, and this is the percent error here is somewhat lesser, and the real value is nearer compared to the graph. So if D10 here is 0.159, in our graph a while ago, our D10 is 0.15 or 0.15 only. And here we have 0.159. Okay? So, looking for the values for D30 and D60, we will repeat the same procedure. So, for D60 or for D30, let's look for D30. I will put here. Okay, so here. So x and then y. For D30, so let's concentrate for D30 here. D30 location is here. So D diameter at 30% passing is in between 0.84 and 0.42. And then percent passing, 34 and 22. Okay? So let's put here 0.84, then 0.42, then we have 34, and then 22. And in between here is your 30% passing, and then in between here is the unknown x, or the diameter x. So using again your calculator, you will repeat the process. So if you want to repeat the process, you are to, I should put here, okay, let's put it there, and then we have mode, and then choose one, computer, mode 1, and then you will go back again from the start. And then let's repeat mode stat. So mode number 3. So it should be number 3 here. Oops. Mode 3 stat. Okay. So mode 3 stat. Then number 4 ln x. Then you see this table. Then type there 0.84 equals 0.42 equals. Move to the right column. Then 34 equals 22 equals. I should put here equals. And then AC. And then we have their shift 1 stat. Then 7 reg. Then 4 bar x. Then input 30 x bar. Therefore, D 30 is equal to 30 x bar here. Then we have 0.667 mm. In our graph, our D30 is 0.64. Then for D60, again, you will have to click mode 1, mode again, and then computer. Then let's repeat the entire process for D60. Again, using the calculator, go to mode, stat, or mode 3, stat, then choose 4 ln x. Then you see this table. In this table, you will input this data. So 60% is in between 64 and 54. Therefore, we will use this data because the diameter is between 2.38 and 2. Okay. So let's go back here. 64, 54. Okay. So we have there 2.38. Yeah, 2.38. Okay. Again, this is 2.38. Then 2.0, then 64, 2.38, then equals 2.0 equals, go to the right column, then right there 64, or input 64 equals 54 equals, and then AC, and then shift 1 stat, and then you go 7 reg, and then since 60% passing is in between here, therefore we're looking for bar x. So 60 x bar here, therefore D 60 is equal to 60 x bar. So that is equal to 2.22 mm. So in our table, in our chart here, our D60 is 2.5. And we have here 2.22 value. So see how the gap is for the values in the calculator and the values for the graph. So there's a discrepancy. And as for percentage error, the lesser percentage error goes to the calculator. Because here, when sketching the graph, we have human error, so our hands is shaky, or we might put the points in the wrong location. So those are the errors we encounter in plotting this graph. That's why if you're in a hurry and if you're in your board exam, if you master this technique of using your calculator, and if your calculator has this function, then it's really very helpful. Okay, so finally we have values for the 60, the 30, and the 10. So we have here the 10 is 0.159 mm, the 30 is 0.667 mm, and then the 60 is 2.22 mm. So here we have 2.22 divided by 0.159, that is equal to 13.96. D30 0.667 squared over D10 of 0.159. So 0.159, D60 of 2.22, that is equal to 0.667 squared over 0.159 times 2.222. Oops. By 1.26. So 1.26. Okay, so again, let's go back to the table. Okay, again, we are choosing between SW and SP. Now, let's get the values for CU. Our CU is 13.96. So, it's 13.96. Is it greater than 6? So 13.96, it's greater than 6. Yes, indeed, it is. So let's have a bigger check mark there. How about CC? CC is 1.26. So the value is 1.26. Is this between 1 and 3? The answer there is yes, it's between 1 and 3. Therefore, our soil is SW. So, SW, and then let's cross out these ones. Okay, so that's how you use this table. It's very tedious, but if you get the hang of using this table, then it will become very helpful. So, let's put here, therefore, the soil is, soil A is SW. Okay, so that is for soil A. Now let's go to soil B. So this is letter A. Classify soil B using USCS method also. Okay, so using USCS method and using this table again. Right, so let's start with the first criteria on the leftmost portion. Let's choose between these two. And we are focusing on sieve number 200. What is the percent passing for sieve number 200? Okay, so before we proceed for soil B, screenshot first the solution for soil A. So this is soil A. So that is 4 soil A, and the table for soil A is this one here. Okay, now let's go to soil B, because I'm going to place here. So let's concentrate on soil B. Percent passing for number 200 for soil B is 33%. So if this is 33%, meaning number 200, 33% passing. So we have here 67% passing. Therefore, we can conclude that the soil type is a coarse, gravelly versus the fine. So 33% passing, 67% retained. Therefore, it says here more than 50% retained on number 200 sieve. So we will be choosing the upper portion. Cross out the lower portion. Okay, next, let's choose between these two. Concentrate on sieve number 4. So what is the percent passing on sieve number 4? Sieve number 4 here, percent passing is 100%. What can we conclude if in number 4, the percent passing is 100% and the retained percent is 0? So, meaning the soil is finer. So, if it is finer, then it's not gravel, of course. So, there's nothing retained. Therefore, let's go to here. Sands, or that is more than 50% passes number 4 sieve. So again, we will choose between these 4. So let's go to this portion here. And again, what's on sieve number 200? Sieve number 200 passing is 33%. So if that is 33%, so less than 5% passing, no. Okay? So how about this? More than 12% passing, number 200, yes. Then it says here 12% passing, number 200 sieve, no. Therefore, this 4 here is eliminated. Okay? So what are those that has been eliminated? So obviously, this one here, gravelly, is already eliminated a while ago. So what's eliminated here is SW and SP. So we will choose between SM and SC. So what's the criteria for SM and SC? For SM, it says there, Atterberg limits plot below A line or the plasticity index is less than 4. So you have two criteria to follow. So it says there, the plot. So this is the where you observe the plotting. So Atterberg limits plot below the A line. So this is the A line. Okay? Or plasticity index is less than 4. And for SC, we have Atterberg limits plot above A line or plasticity index greater than 7. If this, if you want to check, so let's plot it. What's the plasticity index? Is it given? Because it says here plasticity index versus liquid limit. So we have here the liquid limit and the plastic limit. But it says there plasticity index. Plasticity index or PI. Therefore, we need to solve for the PI first. Okay, so letter B. PI is LL minus PL. The liquid limit there is 46 minus 29 PL. Therefore, PI is 17. If PI is 17, okay, so let's plot it. If PI is 17 and then LL is 46, then we can already plot it here. PI is 17, so most probably around here. Okay. How about liquid limit is 46, so around here. Okay. So if we plot it, so it is 17, so it will be here, and then 46. Okay, and then we have there 46, right? Okay, so they have their, we do it right, okay. So it says there, now here is the problem with the plotting for me, because we don't have the accurate measurement here, this portion. Now, what I'm doubting here is, it's very fine when it comes to the location of the point. So we cannot absolutely consider in which portion it went, because it could also be directly in a line. But to ease our doubt, so to remove our doubt, we have another criteria, the plasticity index. Okay, so this is our savior here. The plasticity index for SM is less than 4. The plasticity index for SC is greater than 4. Therefore, if you see the value for PI here, the plasticity index is, so is this less than 4 or greater than 7? It is greater than 7. So if it is greater than 7, therefore the classification is SC. So the answer here is SC and not SM. Okay? So therefore, so we can put here. Okay. Oops. Therefore, soil B is SC, thanks to the plasticity index. Okay? So that's for letter B. Okay, and this is the table for soil B. That is using USCS. Right? So we're done with number 4. Let's go to the next example, number 5. Classify the following soils by the AASHTO classification system. So we have 3 soils. We have soil A, B, and C. So let's use the table for AASHTO. Okay, for soil A, so let's have the process of elimination once again. Now, how do we use this table again? To classify according to this table, we must apply the test data from left to right. So the rules is set here in our study guide. So where is it? Okay, here. To classify, it says there, this portion here. To classify a soil according to the table, one must apply the test data from left to right. By process of elimination, the first group from the left into which the test data fit is the correct classification. Okay? Okay, so let's apply that. Let's concentrate first on soil A. So for the first table, we need to look at number 10. Sieve number 10. Sieve number 10 has a percent passing. So it's percent passing here. So it is 83%. So if it is 83% for number 10, is the criteria here accurate? 50% max? The answer here is wrong. Okay, so let's use the red one, X. So it's in this portion here, A-1-B. Next, let's go to number 40, sieve number 40. Sieve number 40 has percent passing 48. So already eliminated. A-1-A is 50% or 50% max. Satisfy this 48? Yes. Next, let's go to number 200. For number 200, we have a percent passing of 20. Percent finer of 20. So here is 25 max satisfying that? Yes, it is. Then, let's go to the plasticity of the soil. So for the liquid limit, we have 20. For the liquid limit, we have 20. So, yeah, it's blank and it's acceptable. So that is 20. Then we have plasticity index of 5. Plasticity index of 5, 6 max. So again, it is correct. Therefore, the soil here, for soil A here is, so for A, therefore, soil A is, we are not done yet because we need to find the GI, the group index. Okay, according to this, we need to find the group index. The one in parentheses. But we can have a shortcut here. We already did a shortcut. If the classification of the soil falls under A-1-A until A-2-5, then GI is equal to 0. So there's no need to compute for the GI because having this knowledge, we can already put their GI as 0. Automatic. So therefore, soil A is A-1- so again, A-1-B. Then parenthesis, GI is 0. So this is the answer. Okay? So that's how you use the table. Let's go to B. Soil B. Again, let's use for another table for soil B. Okay, start with number 10 sieve. Okay, for number 10 sieve, we have there 100% passing. So looking at the table, we have there 50 max. So we cross that one out and then we check here. Okay, and then let's go to the sieve number 40. Sieve number 40 has 92% passing. 92% passing. So 50% max is not satisfying that. We have 51 minimum, A-3. Let's go to number 200. What's with number 200? We have here 86% passing. So, is 10 max satisfying that? No. Okay? So, 10 max meaning the maximum is 10. And it says there, percent passing for number 200 is 86. So, it's wrong. How about 35 max? No. 35 max. So, I should have looked. It could have saved us a lot of trouble if I look first here, this portion here, for us to choose which one to use, the upper or the lower. This is for the granular material, and this is for the finer material. So we have number 200, sieve number 200. At sieve number 200, we have passing 86. Therefore, so 35% less. If passing 86, therefore that is finer material. Therefore, we're choosing this one here, not here. We're choosing this one. Okay, so for sieve number 10, blank means okay, accepted. Number 40, okay, accepted. Number 200, 86, 36 minimum, accepted. Let's go to the plasticity. Liquid limit. Liquid limit is 70. So 40 max here? No. Rather, let's go to 41 minimum. Because we have a 70 liquid limit. Okay? Then let's go to the plasticity index, 72. So 72 plasticity index, so no. This one does not fit the criteria of 10 max. Obviously, we don't fit for 40 max, but we fit for 10 minimum. Okay? Therefore, the classification falls. Oh. So, there's an X mark here at 40. So, let's proceed to here. So, 41 minimum. Correct? And then 11 minimum. Okay? So, we need to choose A-7, A-7.5, A-7-6. And look at this portion here. If we fall under A-7, for the criteria for A-7-5, PI is less than or equal to LL minus 30. For A-7-6, PI is greater than LL minus 30. So what is LL minus 30? So we have here LL, our liquid limit is 70. So we have there 70. So LL minus 30. Is that 30? Yeah. LL minus 30 is equal to 70 minus 30 is equal to 40. Okay, going back to the table. 40. Okay. So if this is 40, this is equal to 40. So which one does fit the criteria? Our PI is 72. PI is 72. So 72 is greater than 40. Therefore, this one here fits the description. A-7-6. PI. Okay. So plasticity index. Okay. So 70. So we have A-7-6. There, we still need to solve for GI. So according to our study guide here, it falls on this green here. Therefore, we need to solve for the GI as a whole. So solve GI as a whole. Okay? So we need to solve for the GI. Okay? Let's write the formula for GI. GI is equal to... Oh, so... Okay, so there's a clarification here. It's 32. So from our copy, it should be 32. Soil B has a plasticity index of 32. So that's it. Okay. So if it is 32, then equals 40, then this is 32, therefore 32 is less than 40. So therefore the soil is A-7-5. So A-7-5. Okay? So we have here, we need to solve for GI. GI. So GI. So GI is equal to, what's the formula for GI again? That is F 200 minus 35. Then we have 0.2 plus 0.005 LL minus 40 plus 0.01 F200 minus 15. Then we have here PI minus 10. So GI is equal to F200 of 86 minus 35. And then we have 0.2 plus 0.005. LL is 70 minus 40. And then we have plus 0.01. 86 minus 15. Then PI is 32 minus 10. So GI is 33.47, or that is GI equals 33. Therefore, soil B is A-7-5 parenthesis 33. So that's the answer for soil B. And then this is the table for soil B. Okay. So okay, now let's go to soil C. Okay. For soil C, let's use this table. Right? So for soil C, we have number 10, Sieve, 48% passing. Okay, so just have to right. So we have there 48% passing for soil C. Now let's go to here. let's have first the sieve number 200. For sieve number 200, we have 6% passing, so we can conclude that that is gravelly. Okay, so if 6% is finer, therefore it is gravelly. So we're using this and not this one. Okay. Next, we go to number 10. So sieve number 10 is 48% passing. So it fits the criteria 50 max. Next, let's go to sieve number 40, and that is 28% passing. It fits the criteria 30% max. Next, 6% passing for number 200. It fits again the criteria 15% maximum. Now let's go to the liquid limit and plasticity index. This is non-plastic, therefore it fits this criteria. So therefore our soil C is, and also take note that it's in this portion here. So in our study guide, that is GI is equal to 0. Okay, so that's how fast you solve for soil C. Soil C is A-1-A parenthesis 0. So that's for soil C. Yeah, I think we need to continue this in a third video. So I did not expect that, yeah, we will be doing a third video for this. Okay, so stay tuned.